Hello, this is a presentation that was given at CIAC 2020 in Ciudad Obregón in Mexico. And it concerns the contribution of probiotics to the production of shrimp and the improvement in the production of shrimp. Now, when we look at the challenges that are faced by the shrimp industry in this graph from the goal 2019, you can see that basically disease is extremely important. Actually, disease is always ranked as the most important issue faced by shrimp farmers all around the world for many years. What was interesting is, of course, in the last few years, production costs became the second most important issue faced by farmers. So these are really the two key issues that farmers have to handle, have to cope with. Now, when you look at the disease specifically and looking at Asia, farmers have had to cope with white spot, then EMS, HPND, and EHP. And what they have done is they adapted the design of the farms, but also the way they manage their operation. And for example, it means changes to the measures for biosecurity, the kind of products they use, the dosages, the frequency of application, but also looking at how they can handle the waste. And it's especially important for EMS, for Vibrio. So they have modified ways of controlling the accumulation of waste in the pond, and also the control of the water quality. And obviously, in all these diseases, you need to find a way of screening your PLs in order to make sure that you start with clean animals. Now, farmers found solution. In these graphs that were shown by Robert McIntosh at INVE 2019, he looked at the recovery of shrimp farmers after EMS, HPND. And what he noticed was survival went up, but never recovered to the level pre-EMS. And when he looked at the possible causes for that, what he identified was, in fact, big difference between successful and unsuccessful crops. And what we saw is basically, you never know when you start your crop, whether it will be successful or not. And you end up with big variability. And that means you cannot predict when you start your crop, what will be the outcome. So in order to improve the production efficiency and predictability, we have to look at the whole production cycle. That means from the broodstock, hatchery, nursery, and the grow out. And basically it means looking at the pathogens, reducing the point of entry, source of contamination, but also controlling pathogens if they are into your system, if they entered your system, and obviously working on the performance of the PL. That means survival and growth. Now, looking at one of the major developments over the last 5 years, it has been nursery. Nursery is not new, it's been around for many years, but what we have seen is with EMS and now EHP, we have seen the development of different designs of nursery. And here, for example, you can see two approaches of shrimp nursery. The upper part is a model which is based on limited water exchange, very intensive, but also with high investment in infrastructure. On the lower picture, it's more a simple design that can be set up by the side of the farm. And that means, according to your situation, as a farmer, you can look at different focuses, different angles to nursery. One of them is focusing on growth. Another one is on biosecurity and consistency. And the final one could be on crop rotation. So there are different angles to shrimp nursery. And here I try to summarize the three different approaches. One of them that we call the booster approach, where you focus on growth. And basically it means higher stocking density of animal, a fairly short culture period, and you harvest animals that are very small, but you operate with a high water exchange. The focus is on growth. The second approach, nursing, you really look at biosecurity and consistency. So you reduce the stocking density, you increase the culture period, you harvest slightly bigger animals, but you work with low water exchange. Reduce water exchange, therefore lower chance of a pathogen entering your system. And the final one that we call the multi-phase, you focus on farm crop rotation. That means you operate under conditions that are much more closer to those of grow out, so outdoor conditions. You stock at lower density, closer to grow out conditions. And then you look at longer culture periods, harvesting animals a bit bigger. Now, when I take the case of the nursing approach, and here these are data from a Vietnamese operation, you can look in this case here, it's 2 PLs per liter that were stocked. And the main points I want to highlight here is that if you look at the different areas of investment for farmer, You have water treatment, diets, power, and labor. What we've done is basically reducing the investment in water treatment, in power, and in labor, and increase investment in diet. And the result, the outcome of this is that you have a much lower production cost. So you have more consistent output and lower investment costs by reducing water exchange and transferring your investment into higher quality diet. Actually, the same approach can be adopted in intensive farming. These are again examples from Vietnam with zero water exchange system, so indoor system. And what we have done there is starting working on the improvement of efficiency, looking at different stocking density. And after the first year where we optimized the output per area with the right stocking density, we then worked on the consistency. And that means, for example, here, crop after crop, year after year, we were able to produce the same level, the same shrimp volume per hectare. Now, what we've looked at is also the way probiotics are understood in the market. This is done, in this case here, it's a recent survey we did among our customers in Vietnam. And we looked at the way farmers understand probiotics. And what you can see here, when we looked at the different health products that are of importance to farmers, water treatment probiotics are the most important one. And after that, you see an interest in the feed probiotics. And only after that, you see disinfectants, immunostimulants, and others. So farmers in Vietnam understand the value of using water or feed probiotics for the better production of the farm. Now, probiotics means many things, but the main point is to understand it is now one of the major components of a standard operating protocols in Asian farms. But the mode of delivery and the dosages have to be adapted to the conditions and to the type of customer. And I think whether it's in Latin America or in Asia, we can see two major types of farmers. You have the family business. In this case, they look at a regular purchase, daily or weekly purchase, and they will look at the cost of use, but also the local advice. Typically, they will go to a coffee shop, talk to their neighbors, and understand what the people do. The other type are the industrial producer. In this case, it's big volume. They are looking at sustainability and predictability and automation. So there are different kinds of mindset and different priority for these two types of producers. And the products and the dosages have to be adapted to their needs. Now, probiotics in the water, here is an example coming from Thailand. And what you can see, of course, the instructions for use are linked to the conditions. But overall, you can look at water probiotics as interesting for water fertilization, so to prepare the water before the crop or maintain phytoplankton bloom, then the degradation of the organic waste, control of ammonia, but also competition with pathogens with Vibrio. And one more time, let's look at what the survey in Vietnam showed us, where we asked this question to our customers: what are the main reasons for which they're using water probiotics? You can see they understand very well how it works. For them, the main purpose are organic waste control, ammonia control, and after that, water color, which means algal bloom. So they understand very well how it works. And after that, Vibrio control. And the control of virus is understood by farmers as not being helpful. This is another kind of product that have to be used for this application. Now, we were asked to talk about India. Actually, India is a huge country, and what it means is it has big diversity in climate. You will have, of course, very warm and wet tropical climate, but also you may have more arid and dry conditions. And on the right, you can see the kind of temperature where Andhra Pradesh or Tamil Nadu may have extremely high temperature compared to the regions such as West Bengal. For shrimp farming, it's the same. You will have some areas like Andhra Pradesh responsible for the biggest part of the production. And after that, you have 10%, 5 to 10% scattered in other region of the region from West Bengal, Orissa, or Tamil Nadu, or Gujarat. This big diversity in climate and in conditions means the way the farmers look at probiotics is also different. They will adapt according to the climatic conditions. So climate, the stocking densities, the crop pattern will vary a lot between the different states in India. And also we have to understand, in the case of India, the majority of the farmers are small farmers. All of them will use water probiotics, but the dosage will vary with the location. And one of the main points to understand is the difference between inland versus coastal. So that means they will adapt according to the salinity, and they will maybe identify areas of priority for the business there. Overall, we can say that in India, farmers invest between 10 and 20% of all health and fertilization costs. Now, majority of farmers in India will go for direct application of water probiotics, meaning they don't brew. The only exception is the brewing that they would do for the water fertilization process. Also, something interesting that we've seen in the last few years in India is the fact that now we need to register the product, in this case with the coastal aquaculture authorities, which is nice. It means focus on better quality product. And also one of their focus has been on correct information on the label, but also the absence of antibiotics. On the right, you can see an example of some of the coating of feed in farms, in small farms in India. Now, when you look at the feed, of course, another way is to look at the focus of the farmer. Some of them will look at the improved growth and FCR. Others will look at the control of EHP&D, EMS, and others look at the control of white feces and syndrome. The point is you can coat manually or use, like in this case here, a concrete mixer. Like I mentioned to you, we have two types of farmers. You have the small business and the big industrial one. The industrial farmers, of course, will look at a way of collaborating with feed mills. So that means the coating of probiotics on the feed is done at the feed mill for them. So they can control labor cost, human error, and focus on automation and planning. Now, when we look at probiotics, what we have seen over the last few years is a dramatic increase in the number of scientific publications on probiotics in shrimp. In this case, I did a Google Scholar search in January, and I looked at the publication from 2003 all the way to now. And you can see year after year, more and more scientific papers are published to document the effect of probiotics in shrimp farming. And here I want to explain one more time. One of the first person to work on it in 1998 was David Moriarty, and he's someone who worked with us. And for those of you who don't know about what he has done, I recommend you look at the video that we have now put. You can look at our website or on YouTube, and you will have a bit more information about his life and how he really dramatically changed the way we use probiotics in shrimp farming. Now, when we work with probiotics, basically you can look at different purposes, but one of them in farm is definitely to see how we can control the presence of Vibrio in the sediment and in the water. And this is done by working with products, with probiotics, bacteria, that you know will be active in the farm conditions. And for example, here, it's looking at the growth rate, the ability of the bacillus that we have to multiply under a range of conditions of salinity and so on, but also compete with the Vibrio. The ability to degrade the waste, it's for example by producing enough enzymes that can degrade organic waste or dead algae, and also the ability to fight directly with Vibrio to kill them. If you combine ability of bacillus to grow and colonize, to degrade the waste, that means removing the food for Vibrio, and then to fight directly with the Vibrio, you can control the number of Vibrio. And in this case, this is data we had from Brazil, when we looked at the presence of Vibrio in the sediment of pond, and we could see by applying our bacillus throughout the crop, we were able to reduce the number of Vibrio in the sediment. Now, a very important point when we look at probiotics in feed is to look at the cost benefit for the farmer. As I mentioned to you, there are three main reasons why farmers would look at probiotics in feed. One of them is looking at reduction of FCR. The second one is Vibrio or white feces. Here, if we look only at FCR, we can make a simple calculation on the benefit of applying feed probiotics. Here, we look at a typical improvement on FCR. Here we know with our products, we can reduce up to 10% of the FCR. And now if you look at typical conditions of a farm in Central America or in Mexico or in Ecuador, we have stocking density of 15 shrimp per square meter with a typical survival of 65%. Based on that, we can estimate what will be the optimal harvest. Now, with our probiotics and a reduction of 10% of the FCR, we can make the following calculation on what it means as investment in feed, reduction of investment in feed, compared to the investment in probiotics, and what it means for the farmer. With the same yield, less feed, the same level of shrimp, you end up with a reduction in the overall cost of production. So these are simple calculations that a farmer can do to document the cost benefit of applying feed probiotics. Now, we say we work with bacillus. I think bacillus means a lot of things, but it's important to clarify the meaning of it. When you say bacillus, actually it means it's a genus of bacteria. And in the case of bacillus, it means you work with gram-positive, aerobic, or facultative aerobic bacteria who make spores. So this is very diverse. So meaning you work with bacillus doesn't mean anything. It's just very vague. Then you have to look at the species, for example, Bacillus subtilis. In this case, they have specific characteristics on morphology, appearance, use of substrate for growth that we use to define them. Now, the next step is to say you work with a strain. In this case, we work with LNG S23090, which is one of the strain of Bacillus that we have deposited in a culture collection in Europe. And that bacteria, that strain of Bacillus subtilis, has very unique characteristics on the ability to grow at a high level of salinity, to grow very fast to compete with Vibrio, or for example, to inhibit other pathogens. So this is a specific strain. Now, why is it important? It's because you need to make sure that you work with the same bacteria every time, not a Bacillus subtilis, but that specific strain. So in our case, we deposited them at the culture collection in Ghent, and we work always with the same strains. That means we can confirm the safety, but also confirm the efficacy of our product. And don't forget also, we work with factories, whether it is in Thailand or in the US, they have all the right certification of quality. So the right bacteria produced in the right way. And I think it's important now to explain a bit the way we produce a commercial product. You can start with the best bacteria, but if you don't produce it efficiently and safely after that, you lose the performance of your product. And here I'll try to explain to you how it works. So you can see on the left, you would have the pure bacteria in a little vial, and you start to produce them in bigger volume, and then in your big fermenter. You let them grow, multiply. Then at a certain time, you induce the formation of the spores. The bacteria will stop multiplying. They will start to make this resting stage, spores. And at the end, what you do, you harvest them, you wash, rinse them, and you dry them. And what it means is each pure bacteria is then produced in big volume, dried, and you have them available as spores. And when you make a commercial product, like the ProW, we take one of the bacteria, subtilis, another one, Echiniformis, and we mix it with other specific ingredients, and we make a commercial product. This is the only way you can be sure that your commercial product will have always the same amount of the specific bacteria consistently. Now, why is it important? We made a probiotic survey worldwide. We took samples from Asia and Latin America, and we collected about 80 commercial products. And we looked at the concentration, we looked at the contaminants, the activity, the microactivity, but also the composition, to have an idea about what was present in the market. And now what we could see is, for example, here's an idea of the kind of product. So you will have some products that are very fine powders, others are much more rough, some are tablets. And there's a wide range of products that we collected and analyzed. One of the first things to understand is, what about the concentration? And here we looked at the concentration of bacteria in the probiotics, and we compared it to what was written on the label. So for example, in this case, we see that only half the product in Asia had the number of bacteria that matched what was written on the label, where another 20% had up to 1,000 or 10,000 times less bacteria. So it's very important because the lower concentration, the lower efficiency, and therefore the higher usage cost, because you need to put a lot more product to get an activity. Now, when we look at the Americas, we had also the same, with the big difference that in America, a lot of products didn't have any information on the label. So on the label, they were not even explaining how many bacteria were supposed to be in there. So they're not lying. They don't even tell you what is inside. But it's very important because if you look in this case, one of the products that we call Probiotic 48 among the 80 we identified, and this product costs you $20 per kilo, you can estimate for a concentration of 10 to the 8 per gram what it means. Now, if the concentration was not to 10 to the 8 per gram, but 310 to the 5th per gram, it means it's 1,000 times less bacteria than what you think when you buy. So for the same product, you should not pay $20, but you have almost to pay $20,000 in order to get the same efficacy. So the product becomes way more expensive than what you think. So the numbers are very important. The next point, we look at food safety. And one of them, we even looked at, for example, the presence of coliforms. So we found some of the product that had coliform bacteria. These are potentially pathogenic bacteria for human beings. We found some. Actually, we had one in Indonesia and 2 in Ecuador that were contaminated. The good news, we could not find any product with Vibrio, but we had some that could be potentially pathogenic for humans. Next step, we looked at the ability of the bacteria that are present in there to inhibit Vibrio. And what we saw, whether it is in Asia or in America, about 1/3 of the bacteria in the probiotics are able to compete with Vibrio. So if people buy probiotics, assuming it will help them fight directly Vibrio, it looks like from what we've done in our market, only 1/3 of them, of the products actually do that. Now, we also looked at the composition using some of the latest molecular techniques, and we tried to understand whether the information on the label about composition is correct or not, or partially correct or not. And what we've seen is about 1/3 of all the products sold that we collected in America were correct. They mentioned Bacillus subtilis, it's a Bacillus subtilis. But many of them, 1/3 of them were incomplete, and we could find almost more than a quarter of these absolutely not in an agreement. So one more time, you may buy a lactobacillus and end up with Aeromonas. You don't know. So this is another very important point to understand. The next step to see, of course, is how the probiotics that you buy, that could be very good products, but how you manage it at your farm. And many farmers have decided to work on brewing. Sometimes it's looking at a way of fertilizing your pond. So you brew you take some soybean or the carbon source that you mix with bacteria, you let them ferment for a time, and you use it to produce alternative nutrients or food for your shrimp. But some of the people look at it as a way to produce more bacteria cheaply. So you take a product, you mix with organic matter, and you try to produce more bacteria cheaply. The problem is then you don't have a control of the quality. It's an example of what we looked at. In this case, it was done in Vietnam. And we looked at the composition. We analyzed product ourselves, or we send them out to external laboratory. And you look at the composition, the concentration of bacteria, but look at, in this case here, they had Vibrio present in the liquid product that was brewed at the farm, and also fecal coliforms, meaning, again, bacteria that could be dangerous for human beings. So you work with products that are, at the end, very unidentified, undefined. It's very difficult then for a farmer to work on predictable output when you don't know what you put into your pond. And I want to close by a survey that we did with farmers when we were there in Mexico. And the question we asked them was, what was their opinion on probiotics? And we tried to find out whether they thought probiotics were easy to use, very simple, or product that requires some experience, but they could do it with an expert, or whether they required experience, work on traceability, and they believe it had to be a product which is registered from a proper company. The good news is the vast majority of the people we discussed with in that survey with customers in Mexico believe that it has to be done together with a company, with a registered product with full traceability. So one more time, what we are seeing in the market, what we see as the mood of a farmer goes in the right direction, which is to work with a well-defined product so the farmer understands only by working with this kind of product, they can have a more predictable output on their farm. And I would like to conclude. So basically, if you look at that, we have a new focus on microbial management. This is based on improved scientific knowledge. As you've seen, many more research papers being published. But also, you have now the availability of well-defined product and registered product in the market. At the same time, we have a new design of farming, which is based on a better understanding of microbial dynamics. So it allows farmers to understand what is going on and to make take the right decisions, the right approaches when they are faced with a new challenge. And again, I would finish by saying that there's a confirmed benefit now of quality probiotics for the control of Vibrio in hatchery, nursery, and the grow out. Thank you very much.